In section 2, we're going to work on graphing parabolas. Now, we've already worked on graphing parabolas, which we did in chapter 1 when we were studying quadratic functions. These are a little different. In chapter 1, they always either opened up or down. In this section, they can also open right or left. So sometimes they open up or down, sometimes they open right and left. And this is where we're going to begin combining in sections of 8.6. So the section 8.6 we're not going to be doing as a separate section. Instead, I've taken all the learning objectives from 8.6 and I've moved them into 8.2, 3, 4, 5, and 7. So we're going to work with graphing parabolas that are centered at the origin, 0, 0, and also parabolas that will be centered anywhere on the Cartesian plane. So your learning objectives are being able to graph parabolas and write the equations of parabolas. And what you're going to need to understand to do this is this vocabulary about what is a focus, what's a directrix, what's a parabola, and what's the vertex. So right now you should already know the parabola and the vertex, but focus and directrix are new ideas for you, and we're going to go ahead and learn what those are all about. So this is a problem that we might have to solve in terms of developing the parabolic reflectors. So Eurodish parabolic reflectors are used for a lot of things. They're used for focusing energy. They're used for capturing radio waves. They're used for capturing a lot of different things. The Eurodish is developed to provide electricity in remote areas, and it uses a parabolic reflector to concentrate sunlight into a high-efficiency energy engine, located at the reflector's focus. The sunlight heats helium to 650 degrees centigrade to power the engine. So we might want to look at the depth of the dish, write an equation for Eurodish's cross-section at its vertex, 0, 0, and then and a cross-section, of course, would be if I took a slice of this, which, if you see, look at this dish, a slice of this dish creates this parabola right here. It's rather flat, and you know the vertex would be right here. And then as we go on, up here where the engine is where the focus is. So if we wanted to find out how deep the dish was, we would have to sort of take a measurement between here and there. Okay, so let's go into some of these parts before we do that. So the focus, let's take a look at the information you already know. This is a parabola, this is the vertex of the parabola. It's always the highest or lowest point. If it opens up, it's the lowest point. If it opens down, it's the highest point. Adding in the concept of opening right or left, if it opens to the right, it is the leftmost point, and if it opens to the left, it is the rightmost point. Okay, we know that the vertex is here. And we know that there's an axis of symmetry that comes through here. So there is a point on the axis of symmetry that's called the focus. And in the case of the previous problem, the focus is where we would locate the engine, because as light would come down and hit here, it would reflect into the focus. And then another item that we needed to know about is the directrix. The directrix is a perpendicular line to the axis of symmetry. And what's important to know is that the distance from the vertex to the focus is the same distance from the vertex to the directrix, just going in the opposite direction. In fact, every point on the parabola is equidistant from the focus and the directrix. So it doesn't matter where I pick a point. If I pick a point all the way out here, it is the same distance from the focus as it is from the directrix. Okay, so the directrix is a line, the focus is a point. Okay, and when we start working with parabolas, this distance, I told you that the focus and the directrix are equidistant from the vertex, just going in opposite directions. This distance is called P. Okay, so if I go from the vertex to the focus, I will travel the distance P, and if I travel from the vertex to the directrix, I will travel the distance the opposite of p, so the opposite direction. Okay, and it doesn't matter which of the forms I'm in, that's always the way it works. Okay, so let's go ahead and look at how this works. These are for, in 8.2, they deal just with parabolas that are located with a vertex at 0, 0. So these are a very specialty case. But the full equation looks like this. And the vertex will always be at hk. Now these aren't different formulas. This formula becomes this formula if h and k are both 0. Okay, and then p, of course, is the distance that we need to move, and we find that by taking this coefficient, whatever number is here, and setting it to be equal to 4p. So if we want to take a look at how that works in practice as we graph, I know that my vertex will be at hk, remembering that it's, in this particular case, I'm at, using this formula, x minus h squared is equal to 4p times y minus k. Okay, in this case, h and k are both 0, so my vertex is at 0, 0. And now I want to find p. So my vertex is here at 0, 0. And I want to find p, so I know that 4p will be equal to, right, remember whatever coefficient I have here, so 4p would be equal to 20. And that means that p is equal to 5. So what direction am I going to move? So this is, if you think back to chapter 1, this is very similar to that. Remember, we were working with y is equal to ax squared plus bx plus c. This is standard form of a quadratic, and you'll notice that x is being squared, but y is not. And you notice here, x is being squared, but y is not. So this is a vertically oriented parabola, and my p-value is positive, so I know it's going to open up. So 1, 2, 3, 4, 5. Here's my focus. So my vertex is at 0, 0, and my focus is at 0, 5, because I moved a distance of 5 from my vertex. And it was positive, so I moved up. Now, when I want to put in my directrix, it's 5 away from here as well, but in the other direction, 1, 2, 3, 4, 5. So this would be a point on the directrix, but the directrix is a line that is perpendicular to my axis of symmetry. There's my directrix. So my directrix is at y is equal to negative 5. Okay, and now if I want to go ahead and put in some more points, I know my parabola comes through here. It goes around the focus and passes through the vertex. If I want to get some points, I'm going to want to pick x and y. Now, if I picked values of y, we don't normally do that. I would have to then square root to find x. It's easier to find values of x. I'm going to pick 1 and 2. So 1 squared is equal to 20y, so y will be equal to 1/20th. 2 squared is 4 is equal to 20y, so that would be 1/5. And if I plot that, 1/20th, 1/5. Now, if I use -1, if I square it, it's going to end up with the same result. And I knew that anyway because my parabolas are symmetrical. Right? So I'm plotting on either side of the axis of symmetry. And there's my parabola. Okay, so that's how we graph them. I locate my vertex. That's the first thing I want to do. Then I wanted to locate my focus by finding P, right, which it gives me the distance I have to move. That's what's important. Then I located my directrix. That was the third thing I did. And the fourth thing I did was I did an input-output table. Okay, so let's do another example like that, only now we're not centered at 0, 0. I know that I'm working y minus k squared is equal to 4p times x minus h. This is the formula I'm using. So I know in this case k is equal to 1 and h is equal to -6 because this is x minus -6. That means that my vertex, this is the first thing I want to find, my vertex is at -6, 1. So let's go 1, 2, 3, 4, 5, 6, 1. There's my vertex. Now, you'll notice that unlike the quadratic functions we worked with in chapter 1, now y is being squared and x is to the first power. That means this opens to the right and to the left. So if I'm going to find p, I remember that 4 times p must be equal to this number 4. So if I know that 4 is equal to 4 times p, p will be equal to 1. So I come to my vertex and I want to move 1. A positive 1 means a move to the right. There is my focus. So my focus is at -5, 1. Okay, so I moved horizontally 1. That means my directrix is in the opposite direction, and it's 1 away from the vertex as well. So here's my directrix. It is x is equal to -7. Okay, so I have my vertex, my focus, and my directrix. The last thing I want to do is an input-output table. Now, normally we pick values of x and we get out values of y. I think in this case it would be a lot easier to pick values of y. So I'm going to pick values of y. Remember, I've got an axis of symmetry, right? It's running right through here. Let me move it to where it belongs. There's my axis of symmetry. So I want to pick points either above or below the axis of symmetry. Well, I'm going to pick 2 and 3, and when I plug those up into this function, I'll have 2 minus 1, which is 1 squared, that's 1, is equal to 4x plus 24. So if I subtract 24, I'll get -23 is equal to 4x. So x will be -23 fourths. Okay, so 23 fourths isn't quite 6. So 1, 2, 3, 4, 5, 6, and then back 1/4. So right about there. And that will also be true on the other side of the axis of symmetry. And when I plug in 3, I'll have 3 minus 1 is 2. 2 squared is 4. So 4 is equal to 4 times x plus 6. Here, I think it's a lot easier to divide by 4, so I'll get 1 is equal to x plus 6, and when I subtract 6, I'll get x is equal to -5. So here's -5. That will also hold true on this side of the axis of symmetry, and this is my vertex. Okay, so I found my vertex, my focus, my directrix, and I did an input-output table so I could draw this. So it doesn't make any difference whether we're centered at 0, 0, like this problem, or whether we're centered some other location. Just remember that p is a distance that I travel from the vertex. Okay, once I've done that, I can find the rest of my parts. So we want you to practice the graphing, so you're going to do problems 3 and 4 from 8.2, and problem 3 from 8.6, so you can practice the full version of the equation. Come back and we'll learn how to take information and write the equations. Okay, so if I want to write the equation, here we're centered at 0, 0. Remember, we're working with something like this, x squared is equal to 4py, or we're working with y squared is equal to 4px. And the part that I need to find in order to do this is p. That's what I need to figure out. The value, so I need to know the distance from the vertex either to the directrix or to the focus. So they're going to give me something like that. All right, so my if I really quick do a sketch, my vertex is at 0, 0. Here's my vertex. And I know that my focus is at 0, negative 10. So that would be down here. Here's 0, negative 10. So I know that this distance P was a move downward, so it's negative 10. Okay, now, is this item is going to open down, right? So it's going to be in the form which has x squared. So I know that x squared would be equal to 4 times my value of P, negative 10, times y. So x squared is equal to negative 40y. Okay, so very simple. In this case, I'm finding P. It's the distance between these items. All right, now they're telling me a directrix. So same thing, I'm going to draw a sketch. Here's my vertex. It's at 0, 0, vertex at 0, 0. And my directrix is at y is equal to 6. 1, 2, 3, 4, 5, 6. That's a horizontal line here. Okay, that means my axis of symmetry is vertical, so this is also in this x squared form. I know that the opposite of P is equal to 6. That must mean then that my focus was 6 in the other direction. So P would be equal to negative 6. So I know that x squared is equal to 4 times negative 6 times y. So x squared will be equal to negative 24y. Okay, so the directionality of the move helps me to identify which of these forms I'm in, and the distance of the move lets me figure out that it's P. If I'm moving up or down, I would be in this form. If I was moving right or left, I would be in this form. Okay, so let's see that with a slightly different scenario. And for this, I'm going to go ahead and bring out a graph to make it a little easier to measure distance. Okay, so I have a vertex at negative 4, 3. 1, 2, 3, 4, 1, 2, 3. There's my vertex. And my focus is at 1, negative 3. 1, 2, 3. Okay, so this is my vertex and this is my focus. Okay, so we moved to the right. That means that this is horizontally oriented. That means I'm at y minus k squared is equal to 4p times x minus h. And the things that I'm going to need to find are so the things that I'm going to need to find are h and k and p in order to write this equation. So I know that h and k come from the vertex, right? So I have 2/3 of the information are right here. Here's h, here's k. Okay, so x minus negative 4 is x plus 4, and y minus negative 3 is y plus 3, and it's going to be equal to 4 times p, which was the distance we moved. 1, 2, 3, 4, 5. We moved 5, and it was to the right, so it was a positive 5. So my equation will be y plus 3 squared is equal to 20 times x plus 4. Okay, so go ahead and practice writing the equations. Do these 4 problems from 8.2 and this problem from 8.6. Come on back and we'll finish up the lecture. Okay, so if we want to go ahead and solve this problem, we've been given a certain amount of information. We've been told that the vertex is at 0, 0, and so that would be here. In fact, let me again grab a graph just to help organize the information a little bit. If we want to start talking about what this would look like, I have a vertex at 0, 0, and you can see that from 0, 0 we went up 4.5 meters, so 1, 2, 3, 4 and a half meters, and that's my focus. So my focus would be at 0, 4.5. That also means that this distance here is p, and p is equal to 4.5. I have a vertical axis of symmetry. That means I'm going to have a horizontal directrix, 1, 2, 3, 4.5. I don't know that I need the directrix just yet, but I'm just sort of putting in the parts, taking the information I have and putting in the parts that I would know about. So if I want to write the equation, that's the first thing they want me to do. I know that this is going to be an item with x squared. So I'm going to use the full form. It's x minus 0 squared is equal to 4 times p. P is 4.5 times y minus k, which is 0. So I'll have x squared is equal to 18y. There's my equation. And now if we want to know how deep the dish is, you see that the dish is 8.5 meters wide. Okay, so that means that if I go 4.25, 1, 2, 3, 4.25 in each direction, 1, 2, 3, 4.25, this is the width of the dish. So the depth of the dish is going to be whatever is the y-coordinate of my parabola out here, where x is equal to 4.25, right? So what I need to find is this item right here. I know that my x-coordinate will be 4.25 and my y-coordinate will be this distance right here, which is the distance we're looking for. How deep is the parabola? So this distance here. So if I take and plug 4.25 in for x, and let's go ahead and take 4.25 and square it, it's 18.0625. So that's 18.25. So it's about 18. I'm sorry, 18.125. So what I know is that my y value is just approximately 1. Right? So I have 18.125 divided by 18, that's basically 1. So how deep is the dish? It's about 1 meter. Right? Because this is 4.5 meters, we're working in meters. The depth of the dish is about 1 meter. Okay, so that's working with parabolas. In our next section, we're going to work with circles.